hash function. So we will apply it to all columns. And in this way we will create a signature. So there's going to be one signature for each column. And so once we create all the signatures for all the columns, we will end up with a matrix of these signatures. So we'll have a signature matrix. The columns are the sets, and the rows will be the mean hash values in order for that column. And so we said that the rows will get a number, and we will follow the order of the numbers that we get. So first the first one, second the second one, and third the third one, so on. So, for example, let's say this is the input matrix. We are going to create a random permutation. In this case, it's 1, 2, 3, 4, 5, 6, 7. So we will start with the first one, and we are looking for two ones. The first, if we start with the first one, there is a 1 here and a 1 here. So we will use that to create the signature. So this will be the signature for the first row. These two blocks are empty. We go to the second. We will go to the second row, looking for two ones again. To fill in. We can see that in the second row there are, and whatever is here, we don't delete it once it's recorded. We can see there are two ones here, so we're gonna say column 2 has a ones over here, so that we will write the number 2 in there. And then we go to the next one, the third one. The third one has a 1 here, so we will put the third one in that space. So this is gonna be the signature for the first permutation. Then we can do another permutation, and again we start with the first row. First one happens to be here. Now you see this is 1, 2, 3, 4, 5. Now it's the other way around. Starting from the bottom, 1, 2, 3, 4, 5, going up. So the first row we consider will be in the very bottom. There is a 1. There is a 1 here. We're looking for the ones, so there's a 1 here. So we will put a 1 in that box for the second permutation. So there's going to be a 1 over here. Next we go to the second row and look for the ones. There is 2 ones here. So we will place the number 2 here, indicating the second row. And then we go to the third one, and there's a 1 here, so we will put the number 3 here. So we are doing several random permutations permutations, and we use those as a signature. And that's another random permutation. Again, we'll start with the first one. First row happens to be this one, so we will say first is in this box. There is a 1 there. And then we go to the second row. Second row happens to be here. So there is a 1 in the fourth column, so we will put 2 over here. Then we go to third. And the third one. Once they record this box, we're done. We're not going to override it. Third one has a 1 here as well. But this box is already taken, so we will use this box for number 3. So number 3 we will put here. And then the fourth row. The fourth row is that one. There is a 1 here. This box is already taken. So we'll go to the 5th row. And the 5th row has 2 1s. First one is here, that box is already taken, so we'll use the second one, and here we will write 5. So these will be our signatures that we create using hashing. There is a question whether the mean hash value should be the original number of the row or the number of the permuted order. And it doesn't really make any difference. Just whatever we're using, we need to keep using it for all the rows and the signatures that we compute. Once we compute these permutations and create these signatures, the probability that the hash of the first vector or first column is equal to the hash of the second vector, second column, is the same as this similarity measure that we computed here. So if we are to compute probability on those, it will come out as the same number as this similarity. Why is this the case? That's because here we were using the 2 1s. When they both have a 1, we were using that to compute this formula. So 2 out of the 5 descriptions or attributes both have value of 1 out of the 5. And so it is the same with this hash functions that we are computing for mean hashing, because we are looking down the permuted columns until we see a 1. Remember, we were looking for the 1s in them. If both of them have a 1, then this will be, let's say, all of the values both of them have a 1, then they will be equal. But if the row is of type B and type C, then they will not be equal, because B and C, one is a 0 and another one is a 1. So if we consider the signatures that we created, the expected similarity of two signatures equals the Jacquard similarity of the columns. If we use longer signatures, we will make less mistakes because we will more accurately describe the documents. So the error will be lower. Now, if we do this, if we're going to do this with a lot of records, let's say 1 million or 1 billion, then it's difficult to pick just some random permutation. If we have to do all of them, then that's going to be 1 billion new entries. So that's not computationally a good idea because it's going to be very expensive. And if that's what we want to do, then we should just create some approximation. Let's say we want to pick 100 hash functions and use them.